So, I already told you some part of version control systems closer to beginning of this class, when you needed to know at least so much to understand what this abracadabra we are doing approximately is. But now, from all these things, I will go in more details about this last item in this agenda, doing parallel universes of your project or parallel lifelines of your project, which are actually called branches. And what are these and how to do them? First, we can start with tags. And tags are labels attached to one particular commit in your project to mark it with simple name. You can always refer to the commit by its number. If it's subversion, then it is gradually increasing large integer. If it is git, it is like pseudo-random large integer shown in hexadecimal numbers for your hash sum of this commit, and you refer to them for particular version of your software. You may add tag beta 2 or release 1.0, etc. and then you can check it out and use it. And to demonstrate, for example, some of real life projects, here is one open source project I am sometimes contributing to, this eSpeakNG text-to-speech synthesizer. And here is list of all tags assigned to some of commits. And number of tags, of course, is much smaller than number of commits. And for example, if I want to check out some of these particular previous versions, I can do git check out. And then I'm looking now on my workspace on extracted files and folders to this particular commit with this tag. And each of branches starts with adding tag to it, but because meaning for it is different, it is called actually branch. So branch is tag where you start doing parallel universe of your project. If here these circles represents particular commits of your project, and particular commit may have several changed files, and the entire project may have even more files together which are not changed from one commit to another. So if you just add tag here, it is just a label which you can use much easier than referring to commit with particular hash sum. And actually, when I do this, I see that I also could check out or extract files and folders from this particular commit by referring to it with this shortened hash sum. But it's of course much easier to refer to some nicely named tag for it. And then you can also add tag which will be called like a branch. And creating branch, because it actually means adding tag with specific meaning, is very quick and very easy to do. But when you will create new commit, it will not be considered mine, master or trunk branch. So in SVN, this master development branch is called trunk, stumbrs in Latvian. In Git it's called master, but because more and more non-technical people are participating in open source projects, and for non-technical people social justice is much more important than solving technical problems, there was movement that master is offensive word because for Americans and maybe other it reminds about slavery several hundreds years ago, etc., and therefore it should be called mine. So if you use latest and greatest version of Git, then this mine development branch is called mine, not master. So you add branch and you create new commit. This new commit is not considered belonging to this mine or master or trunk branch, but to the branch. And then if you add more and more commits here, it is not considered mine lifeline of the project anymore. And what are good reasons to create branches? First, creating branches is very easy, so you shouldn't be afraid of doing it. But second, you shouldn't be too excited that you can do it. You should always ask yourself, should you do it? Sorry. So, sorry for interruption. Accident happened this night with one of servers I'm providing service, and they needed to understand what exactly happened. Actually, we didn't understand. So, where was I? I was about branches. So, creating branches is easy, but if it's easy, it doesn't mean you should always do this. And there are only two good reasons to create branches. One is to maintain actually two different versions of your software. Like one is latest and greatest, or only latest development version of your product, and another, or maybe more than just one, is still maintained, still supported, released versions of your software which are older, which are actually used in production for your customers. And another is that you want to work on new feature, and you know that it will take some time, and you want to make backups of your project in terms of these commits, but you do not want to disturb all your teammates, your colleagues, with unfinished feature. And here is Lifeline, like a pseudo sequence diagram, shown for these two different cases and reasons for branches. One reason here is about release software, so you release as publicly available version of your software 1.1.1, and then you continue to work on your development branch, but if you find some security issues or whatever, you do not force your clients and customers, like Google does it with Android Studio, to jump to the latest version of your software. You just fix this particular bug in this branch, and then you package it and release it as another update for this stable, usable version of your software. And if you need to support more than one version, then of course you may have more than one parallel branches for these releases. And other thing is, you have to work on some particular feature. You will not be able to complete it within half a day or even smaller time, so it may take a week or two. And of course, when you do different experiments and check does this work or not, you want to save previous state like you do in computer games. So before you start experimenting, you save last known state. So it works at least in such way. Then you do something, was wrong approach, you go back, revert to, and add another commit which actually somehow works. So then again you have particular branch created for this particular feature or this particular developer, and he or she may create as many commits as he or she like, but it not disturb anything in this main development branch for everybody else. And when this feature is completed, then of course you have to merge it back into main development branch. And merging of course is maybe tricky in difference with creating branches. Merging branches may cause you headaches. And merging sometimes happens also between released software and this main release. For example, you may have heard terms called backport. And backport means that some of features or some of commits were merged into older release of software from this development branch. And when Java was released approximately after when new Java release was released only after 2.5 years, so not very frequently, they used backports quite frequently. For example, if you used older Java version 8 with some more security bug fixes and some other updates, some of them actually could introduce new features during these backports from development branch into this release branch. And for example, at the end of life of version 8, you could actually use some of features from version 9 or whatever. Actually, it was something like features from version 8 into version 7, because starting with version 8, they started to use these long-term and short-term releases. So backports now, I think they are not doing backports anymore because release schedule is much shorter. And then what is also important before I explain more details about these commands and lifeline of Git repository. So when you start using like Git version control system quite frequently, one of things you probably will need to start using more frequently is checkout command. And it is related to reset command, but it is different. And where is difference? Difference is following, that in most of cases you do checkout if nothing is added as a new commit into your local repository. So checkout command interacts with your files and folders, and this scratchpad called index, what may be added or may not be added into this index entry. And reset is more far-fetching command, because with reset you actually change something here in history. And these are two important commands when, for example, you do your own development, you have made some commits, you go forward, try this approach, doesn't work, then you probably want to revert it to some previous state with one of these commands, either checkout, which I think is usable in most of cases, or with reset. So checkout, do not change your history of repository, but reset also may change history or how many commits you have in this local repository in your Git database. And then checkout is similarly to some of Java methods. Checkout is overloaded command. To show in more details what you may need to know in your teamwork and in branches, let's initialize Git repository in this test folder, and then we can add some file here. So no commits yet, and we can say something like git add txt and git commit, let's say is message A. So I have following log, and if I want to see it in graphical interface, I do not use heavy tool like Eclipse or, God forbid, IntelliJ IDEA. I use tool called GitK. And here I see lifeline of my project, and here I see what I have made of changes here. And then I can edit this file and write something here. I see that I have modified it. I can check what is difference here. And if I'm not happy with this, like this was stupid attempt, I can say git check out this file, and in this case, because nothing is added into version history yet, this means if I will check out, I will overwrite content of this file this previous version of this file from my Git database. And I have reverted it back. So this is one of things to check out, but problem with checkout particularly is, and even in this lifeline diagram, that they do not show exactly that checkout command is actually overloaded, and its precise meaning depends what kind of information you pass here as the next parameter to it. So if you say git checkout and this is file or folder, then you will revert this file or folder to the state what was previously saved into your version control system in Git. And here, details what I'm telling you is about Git in like Subversion. It's a little bit different, and I have forgotten about Subversion because I have not used it quite a long time. So then we can add some tag. I have not added tags. Annotate. So git tag add, let's say and this commit message. But I can add tag to existing commit. Where is this one? In following way. And then we can refer to existing commit. So this is very verbose, but anything which is unique enough will be also git tag add. Maybe okay, I created a tag called initial. Looks like particularly for tags you are not allowed to use spaces. And now about checkout. So if I said git checkout and here is file or folder, then I reverted this file or entire folder to previous version what was saved into Git database. But if I say and this is name of the tag here, then I actually checked out or extracted from Git database my files and folders from this particular commit with this particular tag. And if you want to go back, and here I have modified my bash prompt, which shows in which particular branch I'm working on. You will not see it if you are working in standard bash. You can always have to write something like with branch, on which branch you are working here. And then you see name of branch here, as here. And so here, because branch may start with tag, actually all branches starts with tag, you add tag to it, and then when you add commits to it, you actually create a new parallel universe starting from this, not for that. For example, if I would add some commit here with this tag initial, then it would create another lifeline of this project as a commits starting from this commit called initial. And to go back to development branch, you say git checkout master, or if you use politically correct version of git, then it is mine. And similarly, we all can check out for particular. Let's make some another commit here. So I have created 2 commits in my lifeline here. And then I can go to this previous commit in 2 different ways. Either git checkout this very long SHA-1 sum, or something shorter which is unique enough. So now I have extracted files and folders from Git database using reference to the hash of the commit. But if I do the same, it is, in this case, it's the same. You can refer to this commit either by its hash sum or by its tag. And for example, so now I see lifeline from initial commit to the C, but if I go back to master development branch, I don't see this commit anymore, because this particular branch, this particular commit was created, was added for the tag, not branch. And here we can see, even though internally data structures are similar, meaning is different. If you check out some particular commit and you do not say that you will start branch here, then this particular other commit, what I did here is following. I check it out. So my here was initial commit, and here was commit with message B, and I checked it out, but I checked it out just as a tag, not a branch, and I added another commit with message C here, and when I went back to the master branch, this now is considered dangling or free-floating commit because you are not allowed to add commits to the commits which are not considered as an entry point for branch. And sometimes this happens if you start checking out different commits and you are not careful enough. You can add another lifeline, another history here for this commit, and it just goes to nowhere. But it's still inside the temporary memory of Git database. And this commit is called detached commit, and you can look, for example, them in different ways. One is git reflog. It shows a list of some of last commits you have used in your database. And here is this commit which I tried to attach or assign into wrong place because I have to add this commit either to the properly created branch or to the master branch, and I can do something like git, which means cherry pick, take out this commit from this history and add it. I think this is this one. And because I modified the same file, here I also got the merge conflict. So this is changes coming from one commit, this is changes coming from other commit, and this is how Git shows them. And I can say that when I solve them, it's neither B, neither C. What about EDD? And then git add this file. And now my lifeline looks something like this. So that's about tags. Now about branches. We do not have created any branches yet, only tags, but we can create branch. So I can create it. There was command to create it and check out it again. And here is third way what you can do with checkout, and this is name of the branch. So just to sum it up, checkout file or folder, and of course it is git before that, means reset, or not reset because there is command called reset, restore from database git checkout tag or commit is extract from this commit, and git checkout branch extract from this branch. So I have extracted from this particular branch, but of course currently I do not have any differences, because when I create branch, it means I actually have tagged my particular commit, and I also allow to start new lifeline from this particular commit with this particular tag. But if I do, let's say, if I change this, now I see that I have added this another lifeline starting from branch 1. And if I check out, I see only lifeline for this master branch, but I can merge it, and I can say git merge branch 1 or B1, and you see that it happened without any problems at all. Why? Because currently I didn't have any content conflicts, because this particular file was changed only in branch B1, and my history here actually looks straightforward. Even though I added this tag here starts branch 1, it here looks like just as a label, because development of my project is still linear. There is no any parallelity happening here. But if I do now I have changed this file concurrently in two parallel branches. In branch B1 I changed its content to FFF, but in master to GGG. And now if I say git merge branch 1, I got merge conflict. Status is following that I have message both modified for 8axt, and when I look inside it I see this is a block of code and this block of content coming from head or master branch, and this is content coming from B1, and in most of cases I use either this or either that or both, or to prove that Git cares only about references to the commits, I can say that when I merge them, actual content is following. And now here I see parallel life of my project, and of course here it's quite simple, only one file is changed. For this particular commit, file 8.txt was changed to GGG. In branch B1 it was changed concurrently or parallelly to FFF, and when it was merged it became to HHH. So this is just a reminder to you that Git doesn't care what content of files do you have when you merge or whatever. What Git cares about how these commits refer to its parent, and this particular commit refers to two parents. And that's it. And then, depending on what is considered parent for this commit and these files, it always shows this difference calculated on fly. So it takes content of this version of the file and content of this version of file and compares it. So in this history, it's not like a putting building block on top of existing foundation. Everything is new content for this file, and these differences, how it was built on top of existing thing, is just computed difference. This difference is actually not stored in Git database. This works in all databases, in Subversion, etc. What is actually stored is a content, and differences are computed depending on what is shown as a predecessor of this particular content. And so that's about particular branch in one particular project. Now let's do following. So I have created also remote repository, and now I will show where you may have problems with merging without branches, but with concurrent development. So these two terminals represents two team members working on the same project. So that would be team member 1 and that would be team member 2. And when you start working in a team, important thing is that you never step over foot of your team members. And what does it mean? For example, if you work in team, or everybody of you work on different content on different files. Because if you do it in following way, then merging between your work is very easy. go first pull to be sure that you have pulled it up. And then you push. And here is lifeline on this project so far. And other team member also git pull. And merge happens automatically because different files were changed concurrently, and then git push. And now we see parallel development even without branches. Both of these users actually, or team members, worked on the same branch, but because they did parallel activities in their work, we see that there still parallel development existed. So now here we have two streams of the same master branch, because one team member created file C txt and another created B txt, and when they were merged together, and merge happened automatically because there were no conflicts, everything went fine. So this is why I showed it. I showed it as a proof that you are not required to create branches to work concurrently, parallel by many team members, if you are careful and your commits do not overlap. This means in your commits you are not changing the same file concurrently in parallel, then merging just happens automatically without any problems. But if you are not careful, and this, I edit this file as well. So, for example, if this team member will try to push immediately, he or she will get conflict. Server will refuse it to push because this user tries to add changes to wrong commit. So, in this remote repository, we had some commits, and last commit created here was commit E. But this user from this side wanted to add new commit to this previous commit with commit J, and of course that is wrong, because to add something, new commit should be added after that one. So when this user tries to do git pull before that, this user has merge conflict, because now it received this file with different content. And again we see both modified for this a.txt. We have this coming from master branch of local user, and this is coming from this remote branch. You see this is that commit here, but is on local repository and that user, and of course because this user pushed it to remote repository, this is last commit on remote repository as well. And again you merge it, either use this or that or both, or you say that when you have merged it, content becomes this one, and then you add it, and then you can push it. So, and then again you see that lifeline of this branch was parallel of master branch, and then it was merged. So for this file, content was changed from HHH to JJJ, in this from HHH to III, and when it was merged it became to KKK. So this, how can you live with or without conflicts, without any branches, and remember that usually, for example, when you need to introduce some feature, there may be some file which you need to modify in parallel with other teammates. For example, there is one central class which is used as entry point to go to other classes, and you need to implement this other class, and of course sooner or later you'll need to modify this central class which calls it. And of course you shouldn't have just one god class, everything is put in single file. So then every time you do these commits in the master branch, you will need to deal with these merge conflicts maybe for this particular class. Then you may decide to create your own branch until you are done, and then you solve these merging problems once, not several times for each particular commit. But some even say that actually dealing with small conflicts each time is actually better than dealing with large conflicts after you have developed some branch and put together. So I do not have specific preferences which is better, but you just need to know something about the lifeline and about checkout command. So I will not go into details about reset command, but reset command is something like undo some of last commits. For example, so I have added it, but then I did, this was actually bad commit, and then you do git reset, and usually you write it in quite abracadabrish way. So you say git reset and head -1 means last commit in this. What is head? Head is pointer to the last commit. And head -1 means reset or delete actually one last commit starting from the head. So see here, git log, currently I have commit L here, but if I say git reset, unsoft means it will still have in this ref log, which is cached commits, depending on how large your cache is, about all your experiments in your project. If you say hard, it will not even be in this git cache. So, and then your log become shorter. So that's what you also may need to do, for example, but you could also do something like for particular commit as well. Okay, we will undo it. And then we can undo it again. So this is changing your local history. And I think this is minimum amount you should have some understanding about when you are start working in a team. Do you have any questions or comments about this?